Hello learners, welcome to Shareability Uganda. In our online self-study lesson today, we shall be looking at a topic, matter and energy. Matter and energy, we shall begin by defining what measurement is. Measurement is the process of finding out how long, short, big, small, heavy or light an object is. Mass is the quantity or amount of matter in an object. It is measured in grams, kilograms and other units. And then we also have gravity. These are all quantities of matter and energy. Gravity is the force of the earth that pulls down objects. For example, if you throw a stone in the air and then it comes back on the ground, that force that drags it back to the ground is what we define as energy, the force of the earth that pulls down object. On earth, the gravitational force acting on mass is 10 newtons or 10 newton per meter. The size of the force becomes smaller as the object moves further from the surface of the earth. And then we also have another quantity, which is length, which is the distance between two specific points. And it is measured in meters, centimeters, hectometers and etc. However, the standard units for length is meters. We have various instruments used to measure length, and they include sticks, strides. Strides are small or defined footsteps. We have meter rulers, tape measures, among others. A line segment is a line between 2 points. Also, we can look at another quantity, which is area. It is also a major quantity which defines or dictates matter and energy. It is the total space covered by an object, and it is measured in square units. Centimeters, meters, decameters, kilometers, etc. How do we find the area of a rectangle? Remember, a rectangle has two opposite sides. The longest side is called the length, and the shortest side is called the width. A rectangle normally has 4 sides. We can find the area of a rectangle or a square by multiplying the length times the width. In the example below, you can see how we can find the area of a square by calculating, of a rectangle by calculating the squares. The longest side, which we define as the length, has 6 squares, and then the shortest side, which we said is called the width, has 4 squares. So therefore, we can find the area of this object or the rectangle by multiplying these squares. We count the squares on the width, and then multiply it by the number of the squares on the length side. So the length has 6 squares multiplied by 4 squares, that is on the width, and then we get 24 squares, which is the total sum of the area of this rectangle. Then area of a square. Remember, a square has all its sides equal, so we multiply side by side by side 4 times, which is side squared. For example, we have an area has sides making 4 centimeters. So we shall make 4, which is the total height of the sides. Then we square it. We shall square 4, and then getting 16 as the total area of our square. Then we have another quantity, which is volume, which is the total space occupied by an object, and it is measured in cubic units. Regular objects are objects with specific or definite shapes, e.g. cuboids, bricks, blocks, tins, rectangles, squares, what else? Pyramids. Those are all regular shapes or regular objects because they have definite or specific shapes. How do we find the volume of regular objects? According to the formula stated, we have V equals V, which is the volume, equaling to length, which is L, times W, which is the width, times H, which is the height of the object, equals the volume in cubic units. Then we have irregular objects, which are objects that do not have specific shapes, e.g. stones. How do we find, now like we know how to find the volume of specific of regular objects, but then how do we find the volume of irregular objects that do not have shape, or objects that do not have definite or specific shape? We have two methods that we can use to find the volume of these irregular objects or these objects that do not have specific shapes. One is the displacement method. It is a method used to find the volume of irregular objects. Instruments used to measure the volume of irregular objects include the measuring cylinder or the measuring can, and then an overflow can or the Eureka can. Using the measuring cylinder to find the volume of an irregular object, the procedure goes as follows. Pour water into a measuring cylinder about half full and record the volume of the water, that initial volume, and then gently lower the irregular object tied on a string into the measuring cylinder where we have poured water. And then step 3, record the final volume of the water in the measuring cylinder. Then we get the difference between the initial volume we recorded and then the final volume that we get. Subtract as in the step 4, subtract the first volume from the final volume, as in the first volume that we got after pouring water and then adding the irregular object. Remember, water will overflow and then we record that in that final volume. The volume that we get, or the difference, is the volume of the irregular object. Remember, in cubic centimeters. And then using an overflow can. Using an overflow can, the procedure goes as follows. Step 1, pour water into the can up to the level of the spout or at the brim. And then step 2, put the irregular object tied on a string or thread gently into the can. Collect the water that pours out of the can in a measuring cylinder. Remember, the volume or the amount of the liquid or the water displaced by this object is equal to the volume of it. It is equal to its volume. It will be equal. The amount of water displaced will be equal to the volume of that irregular object. The volume of the stone will be equal to the volume of the water displaced. This is how the Eureka can looks like, or the measuring can. You can see an irregular object placed into the jar containing water. Then water will flow down into this other cylinder down here that has measurements, or that is calibrated, and then the volume that the water takes is the measurement that the water takes after it has overflowed into this jar down will be equal to the volume of the irregular object placed in the upper jar. Then we have another quantity, which is weight, which is the gravitational force exerted on an object by the earth. The standard unit of weight is Newton. Then mass, which is the amount of matter on an object. It is the quantity of matter contained in a body or an object. Machines or instruments used to measure weight and mass include the beam balance, the set of scales, and among others. Then we can look at the differences between weight and mass. Mass does not change from place to place while weight changes. Mass is the amount of matter in an object, while weight is the force of gravity exerted on an object. Mass is measured in kilograms, while weight is measured in newtons. Let us look at floating objects. And what is floating? Floating is when an object stays on top when thrown on water or any other liquid. Objects float because they are less dense than water or less dense than or they float when they are less dense than the liquid on which they are floating. When an object floats on a liquid, two forces act on it: its own weight and then what we call the upthrust force of the liquid, or that liquid that pushes it upwards to prevent it from sinking. Examples of objects that float include cork, plastic, boats, soft dry wood, paper, petrol, paraffin, etc. And then sinking. Sinking is when an object, when thrown in a liquid or water, goes to the bottom of the water or goes to the bottom of the container in which that liquid is contained. Objects sink because they are more dense than water or they are heavier than the liquid in which they are sinking. Examples of objects that sink include stones, sand, soil, metal, glass, nails, coins, pins, clay, etc. Any sinking object displaces water equal to its volume, like we defined like we saw in those experiments while trying to find the volume of irregular objects. And lastly, we can look at density, which is defined as the ratio of mass to volume of a substance, or is defined as mass per unit volume. The density of water is constant, and it is 1 grams per cubic centimeter, and that of ice is 0.92 grams per cubic centimeter. We use the density bottle to measure the density of substances, and it is measured in units like kilograms per cubic centimeters, grams per cubic centimeters, and kilograms per meter. Thank you for watching this video until the end. Please, if this is your first time, give us a like to boost the channel and to encourage us. And also, if this is your first time, please subscribe to our channel, like our videos, and in case of any advice, please contact us. Thank you. God bless you.